Hey guys, today we're going to be starting a new unit and we're talking about quadrilaterals. No more triangles, talking about quads. So that's exciting. The most important thing to remember about a quadrilateral, the part that says quad refers to four. So a quadrilateral is any shape that has four sides. Now just like there's lots of types of dogs, there's lots of types of quadrilaterals. So we're going to be talking specifically about rhombuses today, but before we do that, let's talk about things that are common about all quads, okay? So the sum of all angles in a quadrilateral, they all add up to 360 degrees, all the angles added together, okay? So the way that we would usually employ this is that if I have an angle here, one angle, two angles, three angles, four angles. All four of these angles together should add up to 360 degrees. Okay, so I can add these together saying I have 34 x's minus 3, this angle, plus 81, the second angle, plus 86, the third angle, plus the fourth angle and last angle, 31x plus 1. All of those together equal 360. Now this looks a little intimidating, but it's a lot less scary looking when you just combine the terms that are the same. So I've got 34 x's here and 31 x's here. Altogether that's 65 x's. Then I'm just going to add together all of the ones. So I've got negative 3, 81, 86, and positive 1. When I combine those together, I get positive 165, and that equals 360. Okay. One of the things that some people even do is, for example, if I highlight the x's first, I could have just added them together at the beginning, and then I can add together the second part, negative 3, 81, 86, and positive 1 together to give me the 165. Okay. Then we solve by taking 165, subtracting from 360, and dividing by x, and you get x is equal to 3. Okay. Now we're not quite done yet. It also says that we need to find the measure of angle R. Okay, measure of angle R. So we need to go up and find R. Here's S, P, Q, here's R. And the measure of angle R is 31x plus 1. Okay, so we're going to take 31, and then where the x was, we figured out that x is equal to 3, so we're substituting it back in for x. 31 times x, which is 3, 31x plus 1, plus 1. 3 times 31 is 93, plus 1 more. The measure of angle R needs to be 94 degrees. Okay. Alrighty. Why don't you take a moment and solve the second problem. You can pause the video and try the second problem on your own. So you should have had a chance to give that a shot. Remember that you're adding all of these together and setting them equal to the total of all the angles, which is 360 for any quadrilateral. The 23 x's and 17 x's made 40 x's, and 1 plus 7 plus 102, and then this one doesn't look like it, but you got to remember this is the same as 90 degrees, right? So adding that 90 in gives you 200. And you solve and get x is 4. You substitute that 4 for x into angle R, and you should have gotten R is 93 degrees. Okay? So now that we've discussed trapezoids, let's talk about non-isosceles and isosceles trapezoids, which are one of the types of quadrilaterals. Okay? In order to be a trapezoid, right, in order to consider yourself a trapezoid, you have to have one pair of opposite sides that are parallel. Opposite sides parallel. Okay, one pair, just one. Okay? Additionally, consecutive or non-base angles are supplementary. Okay? They are supplementary. They add up to 180 degrees. Okay? And those are the angles along the base. Okay, so this side, do you see how this line is parallel to this line? Those lines are the bases. There's two bases, a base and a base, okay? And then the angles, one from the top base and one from the bottom base, together they would add up to 180 degrees. So like this one and this one would add up to 180, this one and this one would add up to 180. They're not congruent, but they add up to 180 degrees, okay? So using those properties, we can solve for some figures using these trapezoidal properties, okay? So one of the ways that we do this is typically, I like to divide it into halves because I know that this half of the trapezoid adds up to 180 and this half of the trapezoid adds up to 180, okay? So if 76 and angle A add up to 180 degrees, then all I need to do is 180 minus 76, which is equal to 104. This one plus this one equals 180. Angle A has to be 104. Okay. What about angle C? So the measure of angle C, this one and this one have to add up to 180. So I take 180 and I subtract 143, and that's going to give me 37 degrees. Angle C has to be 37 degrees, okay? Okay, why don't you give the next two a try? So I'd like you to try this one, and I'd like you to try this one. Remember, we draw a line through the arrows dividing the base into two sides, and we're subtracting from 180. You can stop at this one, okay? So for these two problems, you should have gotten 129 and 93 for K and M respectively, and then in angles 149 and 118 for angles C and D respectively. Shut the door. Then looking at angles Q and R, okay, I can split this down the middle, and this is actually for angle Q, this is actually for angle R, okay? Adding those two together should give me 180 degrees. That means this one plus this one equals 180. I just set them, I'm adding them together. The part plus the part is equal to the whole amount of 180 degrees. So I have our first angle plus our second angle is equal to 180. I combine our x's and get 19 x's. And 13, negative 13, and positive 3 is negative 10, is equal to 180 degrees. When I finish solving by adding 10 to both sides and dividing by 19, I get x is equal to 10. Then I need to substitute into the measure of angle R in order to continue to solving for that particular angle. Measure of angle R is 7 times x, which is 10, minus 13. 7 times 10 is 70 minus 13 is going to give you 57 degrees, okay? So just like we would subtract from 180 to get 1 here, we can add the two together and set them equal to 180 if we're solving for x in an equation. Please follow number 2 to discuss isosceles trapezoids and solving for isosceles trapezoids.